G'day there, you're watching the Aussie BIM Guru, and today we're going to be covering a pretty exciting and a pretty funky workflow. We're going to be looking at using Rhino Inside to deal with merging overlapping lines, and we're going to apply this in the context of area boundary lines. Before I start, there might be a buzzing in the background. Some guys just started mowing the lawn outside, so hopefully that's not too loud for the video. Anyway, so merging overlapping lines using Rhino Inside. So I'd like to thank Wasim Yabi for this idea. From Cardiff, UK. I used the Cardiff flag instead of the UK flag. But he essentially came to me with the challenge that when we extract the boundaries of rooms from Revit, often this means that all the curves that line up on the center of these walls, they overlap. And this can be a real problem when we're trying to just generate something like, say, a corresponding area line, because it ends up causing clashes and warnings and all sorts of problems. So he challenged me to find a solution, essentially. So for those that aren't aware of Wasim's work with his team at Topologic, definitely worth checking them out. And we're going to be showing an alternative approach you can use using Topologic in a follow-up video soon. But essentially, he uses topology as a different approach to geometry. So this allows a more abstract way of viewing geometric objects. And you can generate far more complex outcomes and relationships between geometry using topology. So you can do things like this, finding the shortest distance through a network of points. This is obviously a very simple thing you can do with it, but it can go much further than this. So we will be looking at how this can work in a follow-up. Anyway, I've previously done 3 videos in Python for Dynamo, and in each of these I went through 3 steps. In the first one, I generated the centerline boundaries of rooms in Dynamo. From that, I also generated area lines based on these lines. So based on these curves, we could create area separation lines in a view. And finally, we took areas based on rooms and placed them in these. So you could turn a floor plan essentially into an area plan using Dynamo. And I turned these into 3 nodes in my custom package called Crumple, which is available at the link you see here on my GitHub. And these 3 nodes essentially can be used to generate that same workflow in those 3 videos. So it looks a little bit like this. I'll probably just demonstrate the workflow just to show the problems that occur in the workflow from the perspective of overlapping lines. Because this is the problem when you generate those area separation lines and they're based on the wall center line. Obviously you have neighboring rooms and they both have a boundary. So they both generate an area separator line. And as a result, they clash. So this is a problem. We don't want to go and generate all these warnings every time. We want to have a clean area separation boundary line. Because we do end up with these boundaries that are common between rooms. So I wanted to find a way to merge these. And I did try using Dynamo for a while, and it just did not give me the results I was looking for. You can generate a poly surface based on lots of surfaces. You can also merge them together, but I could never get them to join the same boundary because a poly surface always remembers its base surfaces in Dynamo. So instead, I explored it in Grasshopper and found a solution using what's called regions. And we're going to apply this using Rhino inside Revit. So we're going to use Dynamo first just to show the problem using my nodes, and then we're going to use Rhino Inside to generate some model lines, which we're then going to use Dynamo to turn back into area separation lines. So it's going to be a slightly more staggered workflow, but I think it's a really great use of using Rhino Inside. Anyway, let's get started. So we're going to go in and just suddenly see about probably 5 or 6 different programs. So I have Revit, and I also have Dynamo, and I also have Rhino and Grasshopper, all pointing to the same session of Revit. So if you haven't seen my Rhino Inside series, definitely go check it out because I'm not really going to cover how to open and install Rhino Inside or the basics. I'm going to pretty much just do a workflow. Anyway, these are the 3 nodes that I've used to generate this workflow originally. So I might just quickly show the, I guess, the problematic workflow and how we're going to fix it. So in this case, the way that I deal with causing my area separators to be caused on the center line of walls, because currently by default in the Autodesk sample project it doesn't bound this way. What you do need to do is go to architecture, room and area and volume computations, and you need to switch it to at wall center instead of at wall finish. And now all the room boundaries will be on the center of each wall, so you will get common occurrences at the center of the walls where rooms meet, which is perfect for areas because areas we typically are measuring under the walls in most cases as well, depending on your area measurement standards. But typically common walls are measured together. Maybe not corridor walls, but yeah, typically common walls. So what we're going to do is just create a little workflow just to generate some area lines. So what I also need to do is make an area plan. So I'm just going to go View. I'm going to go Plan View, area plan. I'm just going to make a gross building plan, and in this case I'm just going to make it for entry level. Now this should already have some areas and area separation lines, so I'm just going to go in this case and just get rid of them. So I'm going to get rid of all my area boundaries, and I'm also just going to find all my areas. There should be one hovering around here, so I'm just going to get rid of all my areas as well. And we're going to generate some areas based on our rooms and some area separation lines based on them as well. And you'll see the problem occur as a result. Anyway, we're going to be starting with our current document and its active view. So I need to go current document and active view, just to get our active view, which is our area plan. Now you could use a view drop down as well. It's up to you how you source this view if you don't want to have to be in the view at the time. We're also going to get a categories node, because we're going to be getting all of our rooms in this case, because we need to get their boundary. So we're just going to go rooms, and we're going to be using these 3 nodes from my custom package, which is Crumple. In the case of collecting the room boundary, you could use the centerline node that comes with Dynamo by default. The difference between this and my node is that it will check your active area bounding settings. So in this case, it will always respect the way that you're measuring your areas in Revit itself. Which is a little bit different. But what we're going to do in this case is just get in all elements of category in view. So we're going to get all the rooms in the view. So that's an easy start. We're then just going to go and collect our or our room boundaries in this case. And then we should get a set of curves for every single room. And these will be structured as sublists. So each room will gain its curves essentially. So what I need to do is just flatten this, because I'm going to turn these into area lines. So it doesn't matter what sublist they belong to. We're just going to get curves. So we're going to flatten those curves in this case. So I'll just turn my preview off. And in this case, we're just going to generate area lines from curves. So I'm going to go to manual mode. I'm going to take my active view, and this is from Crumple, this node. It's under Revit areas. So I've got those 2 area nodes under there. And my room boundary node is just currently under elements, room boundaries. So I'm going to take my curves, and I'll just go back into Revit so we can see this work. And I'm just going to run. And this should go and generate those area boundary lines. But the problem we're going to see is that we've just triggered a whole bunch of warnings, because on top of each line, there's other lines. So area boundary overlaps cause warnings. And they're not good either. So in this case, we can see we've generated 77 warnings. Imagine if you're in a 60-story tower, you would have just generated 4.2 thousand warnings. We can't afford this to happen in a project. So there is a weakness in the workflow. So we're going to try and find a way to merge these using Rhino Inside instead. So I'm just in this case just going to get rid of these lines. So what we're seeing now is just a Dynamo preview. So I'm just going to, in this case, just cancel this script. We're going to stop exploring that broken avenue. And instead, we're going to start exploring Rhino Inside. So at the moment, under the Rhinoceros tab, I've opened Rhino and Grasshopper. So you see Rhino inside Revit, and you see Grasshopper inside Rhino inside Revit. So computation inception there. So what I'm going to do is begin making a Rhino Inside script. So I'm just going to make this a little bit bigger so I can see what I'm doing. And maybe I'll just, it's always hard to figure out the best way to lay out these windows while you're working in Rhino Inside, because you do need everything to be like quite big. Usually I work on 2 screens, so it does make it a little bit trickier. What I'm going to do in this case is just make Rhino full, and I'm also going to make Grasshopper full. So Revit's in the background at the moment, you can't see it. So what I'm going to do is firstly collect my rooms using Rhino Inside. So I'm going to go to the Revit tab, and I'm just going to go to the input section, and I'm just going to get a model categories picker. And what I might do is just go and turn on a little plugin I've got called bifocals, which essentially just puts a tag on everything that tells you the name of what the element's called, which is really helpful. And if you are using a reference script from my website, you can always just hold down Control, Alt, and left click, and it will actually take you to where this is. So that will actually point where in the ribbon this tool comes from. Really helpful. I wish every program had that feature. It's amazing. Anyway, let's just get rooms. So we're just going to click on this. I'm going to scroll all the way down to rooms. And then we're also going to be applying a filter, so a category filter, because we're going to filter all the elements in our document based on this criteria. So we're going to get a category filter, and we're going to feed in our category, whoops, in this case. So we now have a filter that we're going to apply to the document elements. This is how you collect elements in Rhino Inside, essentially. You filter down every element in the document. I assume this is building what's called a filtered element collector. That's my guess. And as well as this, we're going to be getting a level filter in this case, because we're only going to get the rooms at a particular level. So we also need a level picker. So under input, we're going to get a document levels picker, and I'm just going to work at 01 entry level for now. So we now have two filters. We do need to combine them using a AND filter. So under filter, we're just going to get a logical AND filter. And I'm just going to connect one, and then I'm going to hold down shift, and I'm just going to connect the other one. Okay, so now we're going to collect all the elements in our document that meet this filtering criteria. So we're going to go to element, and we're going to go to document elements node, which is actually under document elements. We'll connect this in. And at this point, we should have the revit elements. So we now have all of our rooms at this level, all 31 of them. Now you could just get the element geometry. Let's try that and see what happens. So we're going to go to element geometry. And we should get boundary representations of the rooms. Now there's a problem with these. That if you zoom in, notice that we're getting the boundary representation based on the finish face. Even though our Revit model is set to center of wall in its area measurement settings, our geometry by default is going to finish face. So this is how the geometry is collected by default in Rhino Inside. So the solution that I had to explore in this case, whoops, I'll just close some tabs there, was, I'll just have to look for Rhino Inside. Whoops, everything's a little bit crowded at the moment. I'll just go Rhino Inside, boundary location, because on the Rhino Inside website, under the beta guides, there's a whole bunch of additional nodes you can install in Rhino Inside that expand the possibility. They call them custom nodes, essentially. So what we're going to do here is we're going to be using a couple of custom nodes in this case. So I think the first one we need is called boundary location. So what you'll do is you just click on this, and it should download a little GHA user object. And then in Grasshopper, you can go File, and you can go Special Folders, User Objects folder, and you can just copy these objects under here. So in this case, I do have a couple of custom objects already installed from Rhino Inside. So the first one I've got is that boundary location, which just lets you specify finish, center, core, etc. But we do need to feed this into an analyze spatial element node. So in this case, you will also need this analyzing spatial elements node. Now we are going to have to modify the Python script inside this node because it's a little bit outdated and the references have changed in Rhino Inside since this was last created. So I'll show you how to do that as well. But once you've installed those two user objects, they'll be under this little custom tab in Revit. So we're going to take an analyze spatial elements, and we're also going to take a create area boundaries. Now, once these have been created, they're actually just little Python scripts that are no longer connected back to this object. So I can just rename this. And in this case, I'm just going to say, room geometry, because I'm going to actually modify how this works. Because at the moment, if I feed this in from my element, so this is the spatial element, which is one thing we need. And as well as this, I'm also going to get my boundary location, which is a drop-down. So we want to get the center, but you can get other ones as well. I'm just going to feed this in as my boundary line. But currently, we're going to get some issues. We're going to get nulls for the geometry, and also, in this case, for the boundary. So it's not giving us what we need. Now, I couldn't find a way to get the boundary lines to work, but I could find a way to get the geometry to work, which we can use. So what I'm going to do is just open the Python editor. And I'm just going to start playing with this Python script just a little bit. If anything, I'm actually going to simplify it quite a lot. So we're just going to I'm just going to open up my reference so I can see what I need to do. So in this case, one problem with the old way this is set up is that the convert namespace has changed in how it's set up. So we're actually going to delete that namespace, and instead we're going to be adding a reference. So in this case, we do need to go common language runtime, import extensions. And in this case, we need to open a bracket, and we're going to import Rhino Inside .revit.convert. And if you don't know Python, don't worry, just follow me. .geometry. So it's a different namespace reference that we need in this case. From here, we're going to change a few things in our code just to make it work. So in this case, we do still want to get the geometry, but in this case, we're not going to be getting much else in this case. So we are going to keep these two functions, but we are going to have to change how the second function works in what it returns, because currently it was using this convert namespace, which no longer is relevant. So what we're going to do instead is we're going to return g, which is our geometry variable, and we're going to say in this case to brep, and we're just going to open and close the bracket to call on the method. And this should take the geometry and use the convert namespace properly, which is perfect. We don't actually need the other nodes in this case. So what I did in my script is I just deleted this spatial boundary, and in this case we just keep a few things. So we keep our boundary line portion of our script, and we keep our spatial element. I'm just going to remove my spatial bounds section, and I'm also just going to not collect all these additional parameters, and I'm just going to OK this. And you can see now we're getting our geometry based on the centerline reference. So obviously I can change this to finish, and we can see we get the finish instead. But I'm just going to remove some of these variables that we no longer need. I'm just going to zoom in and get this zoomable user interface, as they call it. I'm going to take out boundary, take out, I'm going to take out all these elements and just keep my geometry, just to really simplify the node and what it does. So now we just get, in this case, a set of breps, one for each room, which is perfect. So that's one step down. The next thing we need to do is we need to actually go and intersect this geometry with a plane so we can get them as curves instead. There's a few ways you could do this. My favorite way is just to get a bounding box of all those rooms, and we're just going to feed in our geometry. And in this case, I'm going to right click my bounding box, and I'm going to make it a union box, which actually means you deal with everything that comes in as one. So now we have the bounding box of all our rooms. What I can do with this is just check, in this case, the area, or the volume actually. I'll just check the volume, I think. Because what this will give us is the centroid of the bounding box in this case. That's the only thing. We don't care about the volume, we just care about the dead center point of our bounding box. Because what we can do with this is construct a plane. So we're going to look at construct plane, and our origin is going to be at the center, and X and Y in this case, it's just going to be an XY plane at that point. So now we can use this to intersect our rooms halfway between their bounding box. So in this case, I'm going to get an intersect method between a brep and a plane. And I'm going to intersect all my brep geometry with this plane that we've generated. And if I just turn off my preview for my original geometry, we can see now we've got curves that are halfway up that bounding box in this case. We've successfully generated essentially all of our room bounding curves. Now currently all these curves do have overlaps because each room is its own little set of curves at this point. So we do need to manage out these overlaps now. So what I'm going to do in this case is I'm just going to flatten all of my curves because I don't care about the structure of my rooms anymore. I'm just looking at all the curves together. I'm then going to convert everything to a surface. So I'm going to take all these curves and generate a surface, which is going to find all the sets of curves, and it's going to generate surfaces for each closed set. What I can do with this is then union all of these together. So I'm going to get a solid union, take all these breps, and I'm going to generate, in this case, a result which is one open brep. I'll turn off my preview, and I'll just turn off my section preview as well. And you can see that one thing that's really special about how this works is that the brep retains its edges. Now this is something that joining surfaces in Dynamo doesn't happen as far as I'm aware. It actually loses all those common edges, so we can't analyze them inside the surface anymore. So what we can do now is actually just analyze the edges of our brep. And this is something that I think is unique to Grasshopper. So we can take in our brep, and from this we can analyze our different sets of edges. So we're going to get, in this case, what are called, I think, the naked edges, so the edges that have no overlap. We're going to get, in this case, the interior edges, and we're also going to get, in this case, the non-manifold edges, which are not really relevant in this case. We're going to look at the interior ones, which mean there is an overlap between them. So we can just really quickly just generate a custom preview, just to look at the difference between these edges and how they relate. So let's, in this case, get a custom preview, and we'll get some swatches, just so we can have a look at what's being generated. So I'm going to make one of these red. I'm going to make one of these blue, so we can see the difference. So in this case, I'll just generate blue. And I'm just going to generate two custom previews, in this case with a swatch or a material. And then I'm firstly going to just turn off my preview. So let's look at our naked edges first. So these are all the edges that have no overlap. So we can see that we've successfully obtained the boundary of our overall BREP essentially, and then just a couple of elements that don't have a common boundary inside. And what we can do also is check out our interior edges. And we can see now that we've found all those common boundaries as unique curves. So what we've done with this node essentially is merge these common curves, because it doesn't give you two curves for every interior edge, it just gives you the common edge. So we can use this now in Revit essentially, which is pretty exciting. What I can also do is just go and check how many curves I had originally. So I'm just going to get a explode node, and I'm just going to explode all these curves just to get every single individual curve that occurred. And what I'm going to do here is just get a list of length. I just want to know how many curves I had before. So I'm going to go and get, in this case, my segments. And I'm just going to feed them into a panel just by doing a double /. In this case, I may need to flatten my input here. Whoops, not a reverse, a flatten. And we can see that we have 324 segments at the moment, so quite a lot. Let's just go and count how many segments we have after this. So what I'm going to do is I'm going to merge my boundary and my interior edges. Oops, looks like some of my cats just joined the show. So I'm going to merge these into just one list. So now they're together, and I'm going to flatten the output so they're all just sitting at the same level now. I'm just going to copy this list length and this panel. And we can see now that we have 141 curves. So we have actually successfully reduced our curves based on their overlaps. So really, really handy, and something that I couldn't find a way to do successfully in Dynamo, at least not easily. I think there's ways to do it with really complex intersection methods, but to be honest, just not worth the while from what I've seen. Anyway, we're going to generate a stream filter. And the reason we're doing this is because we only want to feed through our data once to create our lines. We don't want to keep constantly feeding it through. This is really common when you're working in Rhino Inside and you're creating elements back in Revit, because you don't want to just keep creating them. You want to make them and then commit. So I'm going to make a button, and essentially when this button is pressed, it will feed through stream 1. When it's not, it'll feed through stream 0, which is empty. So by default, nothing is coming through here. So what I can do now in this point is I'm just going to go and get my active view from the view tab in Rhino Inside. And in this case, I do need to generate a sketch plane. So what I'm going to be doing in this case instead is I'm going to be just using a little Python script again. So I'm just going to get my reference so I know what I'm writing. So I just can't remember these things off the top of my head. And in this case, I'm just going to go and copy this Python script from over here. Whoops. And I'm just going to drag it over. In this case, I'm just going to disconnect my inputs as well, just by connecting a panel and deleting it. And in this case, I'm just going to generate the sketch plane of the view. So by default, I'm just going to call this get sketch plane. So this is a Python script still. And in this case, what I'm going to do is I'm just going to collect, in this case, a area plan. So I'm just going to call this AP as my variable by right-clicking on it. And I'm also just going to generate a sketch plane, so SP. So what I'm going to do is just go open editor. And I'm really going to be reducing everything I have in this script to almost nothing. I'm just going to go and delete everything below this line. And all I'm going to be doing is saying that SP is equal to AP.sketchplane, which is the API method to generate a sketch plane from a view. So AP is the view and sketch plane is the API method. And this should return my sketch plane once I feed in my active view. And in this case, we now have an Autodesk DB sketch plane. And I can use this to generate model curves. So in this case, if we go to the model tab, we can add a model line. And in this case, we need curves and we need a sketch plane, which we now have. So we're going to take, in this case, our curves. I might just make sure, yep, I'm flattening everything. Great. So in this case, I'm going to take my curves, which are currently set to nothing because of my stream filter. And then I'm just going to take my sketch plane. Now, when I run this, it should generate model curves in my current view or my current model. There are 3D elements, so they'll be visible in any view, but I'm going to be working with them in the context of my area plan. So what I'm going to do now is just move over here, just so I can see my Revit model get updated. So if I click on the button and I just give it like a little bit of a solid press, so it's down for just a little bit longer, it should create the model line. So I'm just going to click and hold it a little bit, and what that should have just done is generated model lines in Revit. So I can see now I have all these lines, but I don't have any overlaps because I have 141 instead of that 324 that we had before. In this case, I'm just going to unpin them just so I can have a look at them, because everything comes in to Revit from Rhino Inside pinned. And I can just go and give them a little cleanup if I want. Maybe I don't really like, you know, that area too much, and I can just give it a quick tidy up. But essentially, I can just go from there and just sort of trim them up. But essentially, what happens is every time it meets a new corner, it breaks. So it stops. But what happens with area lines is if you move one or a model line, it moves them as a set. So it's quite handy to have them in this way from Rhino. Anyway, we're going to be using these now in Dynamo to fix up our workflow that we had before. So now we have a set of model lines in our area plan, which is perfect. And now we can make use of these. So I'm just going to go back into Dynamo. So goodbye, Rhino. Thanks for the help. And then I'm just going to go and make a new script. And in this case, I'm going to be generating a set of area lines. So I can use that node that I used before. So in this case, it's a slightly more long script, but not a complicated one. So we're going to get the current document, and we're also going to get the active view. And now we have our active area plan. What we're going to do is just get another all elements of category in view, and we're going to get 2 of these. So we're going to get 2 different categories in this case. So one of these is quite straightforward. We do still need to get our rooms in this case, because we're going to generate areas from these rooms as well at the same time. We're going to turn these into area separator lines, and we're going to place our rooms at the same time. So I'm just going to go down and get a rooms node. So at the moment, we do have some lines in here, and they're just going to be under the category of lines at the moment. So if you can see any other types of lines in your view, you may wish to probably just maybe isolate rooms and those lines by category, and just make sure you don't have any other lines currently in your view that could be misinterpreted by Dynamo as created by Rhino. You can also switch them over to a different type of line as well to pick their categories separately, but we're just going to work with a category of lines. So in this case, we should be able to find a category called lines. And there we go, lines, perfect. So at the moment, everything's running in automatic, but we can see we've got 130 model curves in this case, because I deleted some of those smaller ones, so we've got just slightly less than 141 now. But they're all our curves from Rhino Inside, and these are all our rooms. Oops, our rooms. Cool. So one thing we're going to be doing with these rooms is we're going to be generating areas from rooms using Crumple. So I'll just find areas from rooms, and we're not going to run this yet, but essentially we're going to be taking our active view, and we're going to be connecting our rooms in to generate our areas, but we're going to make our area lines at the same time. So in this case, we do need to get the geometry of these model curves. So we can just use element geometry. And now we have those 130 or so curves in Dynamo. And I just need to flatten this list as well, because currently the levels will be a little bit messy. Great. So I've got all these curves now. And from this, I can generate my area lines from curve. Now I'm going to go to manual mode at this point, because I don't want to generate things just yet. So I'm going to use my area lines from curves. So in my current view, my active view, I'm going to use these curves to generate my area lines when I run. I'm also going to generate areas from rooms. What I need to do at the end is just delete the original model curves, because I don't need them anymore. They've done their job. So inside Crumple, I also have a really common little node that lots of people use under script flow, and I've got a wait for. So in this case, I'm just going to take my original model curves, which are back here. And then I'm just going to wait until I've generated my area lines. And then after that, I'm just going to delete the model curves essentially. So this is going to pass through the model curves once the area boundaries are created. So I can just go get a element.delete node. So there should be one by default now. Yep. And this will just delete those original model curves that were converted. So what we can do now is just run the script essentially, and it should convert these for us. So what I might do, just so you can really see the difference, is I might just go to areas in my view and just turn on their references. As well as that, we'll see the area separation lines show up. But at the moment, there's no areas, so we should see a few things happen. What I might do is just make everything halftone, except for areas, and also except for lines as well. So we can really see those area separation lines show up. And I might just turn off annotation categories as well. Great. So as soon as I run this, we should see our model curves get converted over and deleted, and we should see areas created within those lines. So let's do it. Moment of truth. Run. Something happened. Empty list. I think I've probably hidden my lines. I might just isolate. I think at the moment it hasn't collected the model curves. I must have done something wrong. So I'm just really quickly going to check. It didn't collect any model curves, which is interesting. In this case, I may just reboot my script just to be sure. Sometimes this happens. Bear with me. It will work. I will get it to work. So I've got currently my rooms and these visible. I'm just going to make sure that I've frozen this node and just that I've frozen my geometry. And I just want to make sure these lines are going to come through. Okay, now these lines are coming through. I'll try again. So what I'm going to do is just unfreeze. May have been because I was running in the same session as creating the script. Hopefully now it should work. So I'll just try running. Okay, there we go. So now we can see we've got areas. And the area node does bring the name and the number over as well. But we're also going to have area separation lines as well in this case. So we can see that now we have those area separation lines. And if we just check our area separation lines, we should have no warnings now. And we have no warnings. So very exciting, much cleaner. Obviously what we want. In this case, there's a couple of warnings just for things not joining. But I think these are walls in this case. So I must be somehow selecting some model elements from Revit. But it looks like we have no warnings related to these elements at the very least, which is really exciting. So yeah, there we go. A way to solve the problem, right? And this is a really common problem that comes to me quite often. So hopefully this helps solve other applications of the same overlapping curve issue for you in a more abstract way. Anyway, the files will be on GitHub for this workflow. All the steps I've taken will be scripted and uploaded for you. But there will be a follow-up video that's coming up probably this week as well from Wasim, and I'll probably share it on my channel as well, which is going to show you an alternative approach to this problem, which is much more straightforward using the topologic package in Dynamo. It does require you to think a little bit differently about geometry classes and how topology works. And from there, Wasim will show us how he can make use of this topologic geometry to do some pretty meaningful and interesting studies, because this is really just the first step of a bigger workflow. Now we've got some areas and lines and we can do more things with them, right? So I look forward to sharing that on the channel in my social feeds as well. So thanks for watching today. Hopefully this was an interesting video, probably a little bit complex, and I probably went maybe a little bit too deep for some people, but hopefully some of you made it through the whole video. And I look forward to seeing you in future videos. I try to make videos about 2 times a week. I'm hoping to do so for a while. You might have noticed in my date stamp in the bottom right corner that there have been some gaps in my recording, so I'll see how I go. So thanks for watching, and if you're not already following and subscribing, feel free to do so. Thanks. I'll see you in the next video. Take care. Bye.